Why do we now have a red and orange line, as opposed to just the red line from before? As mentioned in an earlier video, the red line is the relative response variable per weighted record, scaled for each level or each category, so that the base level, in this case 1 through 3 years of college, is exactly 1. Relative to gambling problems for respondents in the 1 to 3 years of college level, respondents up to 12th grade are 33% higher. When we fit a model, the betas for all the variables in the model, such as gender, highest grade attended, importance of faith, etc., are used to score each respondent with a modelled value. Given that a particular respondent might be male, attended 4 years of college, lists their importance of faith as 2, moved house 1 time last year, and lives in the northeast region, etc., their particular modelled gambling score might be 1.4. Somebody else, with a different set of characteristics, might receive a modelled score of 2.3, and so on. Now recall that the gambling scores were on a scale of 0 to 10, with the vast majority of people scoring a 0. So after the model has scored every respondent with a modelled value, Preddle calculates the average modelled score for comparison against the actual score to see how good the model is predicting. The orange line is the relativity of the average modelled value for records or cases in that category. For those who attended 9th to 11th grade, the average modelled value here is 61% higher than the base category, or the base level, while the average actual value is 67% higher than the base level. If your model is performing well, the orange line should match the red line quite closely, i.e. the actual and modelled values should line up with each other as you move through the categories, as they do here. Categories with a small number of records or cases can have a bit of difference between the actual and modelled points, just due to noise in the data when there are so few records to average across. But any categories with a reasonable number of respondents, such as these and these, should line up very closely. If it doesn't, it indicates something with the model needs to be rectified. Let's look at faith now. As I said earlier, this appears to have been a survey question about how important faith is to that individual, answered on a Likert scale, from very important to not important at all. By fitting the cont version of this variable, it has fit a linear line through the levels, as shown by this blue line, rather than giving each level its own beta. If we fit it as a categorical, like this, each level takes its own value. You can see here. Go back to the continuous version. This is the fundamental difference between a categorical and continuous variable. We can fit it as a cat by ticking that one, like we did, but when we fit the cont version, the beta is simply the slope of the line. A beta close to 0 gives a flat line. The more positive the beta, the steeper the slope upward. The more negative the beta, the steeper the downward slope. In this case, we have a downward slope, i.e. a negative beta. Fitting straight lines like this produces a simpler model, since we only need to estimate one beta coefficient for the entire predictor, rather than a coefficient for each unique level. Just to reiterate, for a linear line, the model only needs to estimate one beta, that being the slope of the line. By contrast, looking back at the grouped highest level attended, the model had to estimate 3 beta coefficients, 1, 2, 3, compared to the 1 beta coefficient in importance of faith. Recall that the confidence intervals of the beta reflect the upper and lower bounds of what the model estimates the beta should be. If the beta of importance of faith were at the upper end of its confidence interval, the slope would be greater and the line would follow the upper tips of the intervals shown along here. If the beta were at the lower end of its confidence interval, the slope would be shallower, and the line would follow the lower tips of the intervals shown. That's why for continuous factors you get this fanning out of the confidence intervals. Also interestingly, with continuous predictors, the summed actual and fitted values in each band, shown by the red and orange lines, are less likely to fit together closely. This is fine as long as there isn't a systematic over or underfitting over sections of the predictor. For example, if the red was continuously above the orange for low levels of importance of faith, and the opposite occurred for high levels of importance of faith. If there was systematic over or underfitting of low values or high values, then we might want to move from fitting a straight line to fitting a spline, such as a quadratic or a logarithmic curve. We'll come back to fitting splines in a later video. I just want to point out that there were some missing or blank values in importance of faith. Preddle codes missing values as -1. These all fell into the less than 0 bucket here, since a Likert scale doesn't normally allow negative values. In this case, it fit the straight line to the -1 values as well. In this case, it doesn't seem to have been a problem because the rest of the values fit quite well still. But if it was a problem, all we would have to do is create a new categorical variable to indicate if the response was missing or not, like this. And include that in the model. Now we have a variable that acts as a flag for whether that particular response was missing or not. When we include this variable, as well as the continuous predictor, and refit the model, it allows the model to compensate for the missing values if it needs to. Incidentally, it wasn't really required, although the beta does look to be marginally significant. But for future reference, if you notice that the actual and modeled values are not lining up that well, then try this adjustment and see if it helps. So let's quickly fit importance of faith as a categorical version again and see how that differs. So each band is treated as a category in a categorical variable essentially. Since each band is allowed to have its own beta coefficient, the actual and modelled values fit together perfectly. But this is overfitting the data and leads to some problems. Firstly, excluding those levels with no records, there are 4 beta coefficients being fit. 1, 2, 3, 4. Making it a much more complex model than if we just fit a straight line, which would only require 1 beta coefficient to be estimated. Secondly, there is no natural ordering being enforced. The beta for each level is all over the place. It goes up, then it comes down, then it goes up again. Each level has been allowed to fit perfectly, even to noise in the data. When we had fit a straight line, it enforced a smooth and intuitive shape rather than the rough shape we see here. We want the model to reflect the natural process underlying the data, rather than randomness in the data itself. Having the model fit perfectly to every up and down movement in the sample data probably won't generalize to the population as well as a simpler, straight line model would. As a compromise, we can fit a spline, which is basically a series of piecewise curves or lines over different parts of the range, since a straight line over the whole range might not be appropriate. Spline fitting is covered in the next video.